So this video lesson is about power, but not the kind of power that comes from an infinity gauntlet, but rather the rate of doing work or transferring energy. So power is how rapidly, so how fast work is being done. And so power we usually symbolize with the capital letter P. And it's really all about the rate. So it's how fast we're doing work or how fast we're transferring energy. Power is a scalar quantity. So it has no direction associated with it. Okay, and the unit for power is actually called the watt. So the unit for power is the watt, and it's symbolized by a capital W. And so when we're looking at power, we talk about power in terms of wattage. And so you probably have seen that on, for instance, something like a light bulb, where you have like a 60 watt light bulb or a 75 watt light bulb. And so that's just a measure of how quickly that light bulb is able to transfer energy. Oh, I missed the Y on energy. All right. So the formula for power, so if we are trying to calculate power, power is actually equal to the work done divided by the time in which we did it. And since work is actually equivalent to energy, we can actually say that power is the change in energy over the change in time. Okay, and so what that actually means is that 1 watt is actually 1 joule per 1 second. And so the unit of the watt is actually a joule per second. All right. When we're dealing with power, we very rarely deal with small units of power. We actually deal with a lot of large units. And so I just want to do a little reminder here of our large scales of units. So when we have something that is times 10 to the 3, that is a kilo. So we can have a kilowatt. And so a kilowatt, and the letter would be just a little k. A kilowatt is 1,000 watts. If we have 10 to the 6, we know that that is mega. And the letter for that is a capital M. And so that's 1,000,000 watts in a megawatt. We also can have 10 to the 9, which is giga. And that will be a capital G. And so there are 1 billion watts in a gigawatt. And then we also can have 10 to the 12, which happens to be tera. Oh, only 1 R. And that's a capital T. And so there are 10 to the 12 watts in a terawatt. Okay, so we're going to do an example with power. So an example here. We have this nuclear power plant. That supplies 3.2 gigajoules of energy over 1.5 minutes. So we want to do a couple of things with this. We want the power of the plant in watts. So we're going to measure that in watts. We want how much energy in an entire day. So how much energy would be produced in one day. And I also would like to know how long in hours. So we're going to measure that in hours to produce 375 gigajoules of energy. Okay, so looking at this nuclear power plant, we have our 3.2 gigajoules of energy over 1.5 minutes. So that's how much energy gets created over 1.5 minutes at this power plant. So first we want to calculate what the power of the plant is. Then we want to see how much energy we could produce in one day. Then I want to see how long it will take for me to produce 375 gigajoules of energy. All right, so we're starting with part A. So we want to calculate the power. So we know that power is our change in energy over our change in time. And so our energy was 3.2 gigajoules, and our time is 1.5 minutes. In our power equation, we have to measure energy in joules. We have to measure time in seconds so that we can get our power in watts. So we have to plug in our energy, but 3.2 gigajoules is 3.2 times 10 to the 9 joules. And our 1.5 minutes, we have to convert into seconds. So in 1 minute, there are 60 seconds. So that gives us a total of 90 seconds. So that's going to go on the bottom here in our time. And so to calculate our power, we do our 3.2 times 10 to the 9 divided by our 90 seconds. It's going to give us 3.5 times 10 to the 1, 2, 3, 4, 10 to the 7. And that's going to be measured in watts. So that's part A. That's the power of this nuclear power plant. So part B, how much energy would be produced in one day? So if we do part B, so now we know that the power is 3.5 times 10 to the 7 watts. And we know our time is going to be 1 day, which we have to convert into seconds. So to do that, our 1 day is multiplied by the fact that there are 24 hours in 1 day. And then we got to convert from hours to minutes. So in 1 hour, there are 60 minutes. We got to convert from minutes to seconds. So there are 60 seconds in 1 minute. So that we can cancel out our units. So we can get rid of the days, we can get rid of the hours, we can get rid of the minutes, and we're left with, once we do the math here, 86,400 seconds. Okay. By no means do you need to memorize how many seconds there are in a day, but it's not a bad number to have in your back pocket rather than having to do the calculation or the conversion every single time. If you do the conversion every single time, that's absolutely fine. But often in power questions, they'll give you 1 day as your time unit, and it needs to be in seconds to be able to go into the power equation. And so it's not a bad number to memorize. So here we want to calculate the energy. So our energy, after rearranging our power equation, is going to be our power times our time. And so our power is 3.5 times 10 to the 7, and that's in watts. And our time has to be in seconds, so the 86,400. And so we got 3.0 times 10 to the 12, and that's going to be in joules. But the question asked us to put it, it did not ask us to put it in anything. So we can leave it in joules, or we can convert it to gigajoules if you want. Gigajoules, maybe we should convert to terajoules. That might be easier because we would end up with 3 terajoules, since a terajoule would be 10 to the 12 joules. All right, now part C asked us how long it would take to produce 375 gigajoules of energy, and it asked in hours. So here our power is the same. It's still the same power plant, 3.5 times 10 to the 7 watts. Only now we have our energy is 375 gigajoules. And so we want to convert that into joules. So it'd be 375 times 10 to the 9 joules. And we want to calculate the time. So in order to rearrange to calculate our time, using our power equation, we know that power is the change in energy over the change in time. We're going to rearrange, and so time is going to be our change in energy divided by our power. So we have our 375 times 10 to the 9 joules. And our power was 3.5 times 10 to the 7 watts. So we're going to do that math. And we get 10,714 seconds. And we want to convert that back into hours. So 10,714 seconds. We're going to multiply by the fact that there are 60 seconds in 1 minute. And then 60 minutes in 1 hour. So that's going to allow us to cancel out the units we want to get rid of and be left with hours as our unit. So 10,714 divide by 60, divide by 60. So we get, we're getting 2.976 hours, but we need to round that for significant figures. And so it's going to be 3.0 hours as our final answer there. All right, that's it for calculating power. So there's a couple of different ways to use that power equation. So in part A, in this example, we calculated the power using the energy and the time. Make sure energy is in joules, make sure time is in seconds. In part B, we calculated the energy by rearranging the formula. Again, make sure our power is in watts. Make sure our time is in seconds so that we get joules as our energy. And then in part C, again, we rearrange that same equation, only now we're solving for time. In order to get our time in seconds, we have to use energy in joules and power in watts, and that will give us our time in seconds. Now, often we want to convert our time in seconds back to a time in minutes or hours, but that conversion comes after you've plugged it into the power equation. And so that's the end of this video lesson for calculating power.